So this is a very straightforward exam question on quadratic functions and solving a quadratic equation using a graphing method. So how do we approach a question like this? Well, first of all, let's just have a look at the examiner's remarks. So the examiner's remarks are fairly positive on the whole. The algebraic manipulation in part A, it says, was well done. 68%, so over 2/3 scoring the full 2 marks. The connection between parts A and B, though, was lost on many candidates. So since it came to graphing in part B, there was some confusion. And so solving the quadratic equation at this stage just didn't work. It was pointless, they say. Only 35%, so only about a third, scored the 3 marks available then in part B. And since 62%, so most of the others, scored 0, it was a case of either knowing exactly how to proceed or not having the faintest idea. So there was some misunderstanding here. But part C gave candidates the option of reading solutions from their part B graph or just solving the equation 2x squared minus 9x plus 4 equals 0 using other methods. And both solving it by the graph and solving it by other methods was seen, and over a third scored the 2 marks available. So on the whole, this was reasonably well tackled, although once again graphing was a problem for a lot of students. Okay, well, let's work through it and see what things come up. Okay, so the first thing is that we have to show that 4 divided by x, so 4 times 1 over x, if you like, or the reciprocal of x, 4 over x equals 9 minus 2x. We have to show that that can be written as a quadratic equation, so straightforward 2x squared minus 9x plus 4 equals 0. Now what this is basically is rearranging, and there are going to be, let's see, 2 steps really that we need to go through, and as long as we understand how to do that, then we should easily get this quadratic equation. So let's have a go. We start by multiplying through by x, so if I just put times x as our first step, it's a rather eccentric way of writing this out, but it just gives the examiner some idea of what we're doing. So multiply both sides by x, multiply 4 over x by x, and you eliminate that x. So you're just on the left hand side going to get 4. On the right hand side you're going to get 9x, so you're multiplying through, so you multiply both terms, distributing the x, so 9x minus x times 2x is going to be 2x squared. Okay, so that's the first step. Second step, we're going to be just moving all of these terms over onto the left hand side to join the 4, leaving just 0 on the right hand side. So how do we do that? Well, we're going to subtract. Let's do it in 2 stages. Let's subtract minus 2x from both sides. So let's add 2x squared on both sides. Adding 2x squared to the right hand side is going to eliminate that minus 2x squared. So the next step is going to be add 2x squared. Okay, so we're going to end up on the left hand side with 4 plus 2x squared, and on the right hand side we simply have 9x. Okay, and then the third step, I'll just do a line to separate it. The third step is going to be bringing over that 9x as well. So if we subtract 9x from both sides, we're going to get, let's put subtract 9x. We're going to get our 2x squared. I'm just rearranging as well, so commute this so that we get it in nice descending order. 2x squared minus that 9x that we're subtracting, plus the 4, because we've still got a 4 on the left hand side, equals 0. So there we are. We've shown that 4 over x equals 9 minus 2x can be written as 2x squared minus 9x plus 4 equals 0. Okay, I hope that's clear. Let's move on to part B. So in part B, it says part of the graph of y equals 4 over x is shown on the grid below. We've got to draw a straight line on the grid, which will enable us to solve the equation that we've just been working on, 2x squared minus 9x plus 4 equals 0. Now, what's the straight line that we're going to draw? Well, we've already got y equals 4 over x, so that's the first function. In fact, it tells us that down here. So we could call that f of x if you like. Let's just label it f of x. The second line is going to be just a linear function, and so that's going to help us solve this equation. So it's got to do with this. So it's going to be this term here, minus 2x plus 9. So g of x, we're going to define g of x as minus 2x plus 9. Okay? And you can see that that's a linear equation, but because it's got a negative coefficient, it's leaning in a sort of backward direction. It's not going to be leaning forward, which is what we get with a positive coefficient of x. Okay? So it's going to have a gradient of minus 2, in other words, a long one up 2, but in a negative direction. Now, we also know that it's got an intercept, a y-intercept of 9, but 9 isn't on our graph, so that doesn't help us a great deal. I think what we'll do here is use the method, always a good idea anyway, with linear sequences. So we're going to use the method of just plugging in values of x to get values of y. So we're going to use a table of values. It will fit in quite nicely down here, so I'm going to do it down here, I think. Yeah, that should work quite nicely. Okay. So we start with a little table. So we put x values and y values. Give it a nice, neat presentation. Okay, and that sort of makes the examiner happy. There we go, something like that. And now we've got to choose suitable values of x. Well, we know we want to see it crossing here, so why don't we start with 1? And it's a good idea with linear sequences to go up in regular intervals. So I think I'm going to go 1, 3, 5, and 7, see if that works nicely. 1, 3, 5, and 7. So when x equals 1, we're going to have minus 2 times 1, so that's minus 2, plus 9, that's going to give us 7. Okay? When x equals 3, we're going to have minus 6 plus 9, so that's, brain's not working very well today, minus 6 plus 9 is 3, there we go. Okay? Plug in 5, minus 2 times 5 is minus 10, plus 9 is going to give us minus 1. And just a quick check here of our common difference, because we know it's a linear sequence, so we know what we've got here is an arithmetic sequence. We know it's a linear function, but when we're doing this table of values, we're going to get a sequence as long as those values are regularly spaced. So between 7 and 3, we've got a common difference of 4, and so we should expect a common difference of 4 between 3 and minus 1, and indeed that's what we get. So the next one should be, if we're going into the negative, in fact it's a common difference, of minus 4, because it's getting smaller, so it's going backwards. Okay, so we've now got minus 1, minus 4, we should have minus 5, but let's just do a check. Common difference of 4, minus 4 again. Let's just do a check. We're going to plug 7 rather into here. Minus 2 times 7 gives us minus 14, plus 9 does indeed give us minus 5. So now we've got coordinates, x, y coordinates, and these are useful for plotting our line. I'm just going to change the colour here so that it's easier to see. Okay, so we start with 1, 7, and that's going to give us a mark just there. 3 is going to be here. Minus 1, sorry, 5 minus 1. Well, that's going to be off our graph. So that's going to be 5 minus 1 is going to be off here somewhere. So I'm just thinking where it's going to be sort of there then, roughly, that we're going to be going. So I'm not happy with that. I'm going to add an extra value, which is going to be 4. So if I put my 4 in here, what am I going to get when I plug 4 in? Minus 2 times 4 is going to give me minus 8, plus 9, it's going to give me positive 1. So I'm going to get 4 and, I can just squash that in here, 4 and 1. So that gives me another point to plot, and that's exactly here, which seems to be, in fact, our point of intersection. Anyway, that's given me 3 points. I could do a 4th point here. I could try 2. Let's try 2. 2 minus 2 is going to give me minus 4 plus 9. It's going to give me 5. So I didn't need to do this, but it just helps to reassure me that I've plotted this correctly, and I don't need to now rely on this mark down here. Okay. So I'm ready now to draw my line. So I get out my ruler and draw my line as accurately as I can down here, and it crosses the point here. I think I could have drawn that ruler line a little bit more accurately, actually, but it's good enough, and it does seem to confirm that we've got our point of intersection here. Okay, so it says draw a straight line on the grid which will enable you to solve the equation. How does that straight line enable us to solve this equation? Well, it gives us this point of intersection. It gives us x equals 4 as a solution. Okay. There's also going to be, just to point out here, there isn't real on the graph, but there's also going to be a point of intersection. It's worth just drawing this on, I think. There we go. Now we can't draw it on the graph, but there's also going to be a point of intersection here. So if I extend, there we go. If I extend the quadratic function here, then I'm going to get my point of intersection there. So we're going to expect an alternative x value at about x equals 2/3, because we should get 2 solutions from this, because we know it forms a quadratic equation. Anyway, that's completed part B very thoroughly, so let's move on to part C. For part C, let's just change. There we go, back to this. For part C it says, hence or otherwise solve the quadratic equation, so we could give those 2 points as our solution. But the danger here was that we would ignore this one here. Let's just solve this equation though using, well, let's use a couple of methods. Let's try the quadratic formula. So the quadratic formula, if you remember, is x equals minus b plus or minus the square root of b squared minus 4ac. We know it solves, so we should get a positive value under here, which is the discriminant, all over 2a, don't forget. So what does that come out as? Well, minus b is going to be minus 9, so that starts us off with 9, plus or minus the square root of whatever b squared minus 4ac is. So b squared is going to be 81 minus 4 times 2. And what's c? c is 4. Okay, like that, divided by 2 times 2, which is going to be 4. So all we need to do is resolve all of that, and we should get our 2 values of x. Let's give it a go. So we've got 9 plus or minus square root of, well, what have we got under here? 4 times 2 is 8, times 4 is 32. So we've got 81 minus 32. So we can do this in a couple of stages and avoid calculating too much in my head, which is stressful and a good way of making mistakes. Okay, so 81 minus 32. So I'm going to resolve that bit now. I've got 9 plus or minus the square root of, well, what's 81 minus 92? Minus 32, sorry. Well, it's the same as 80 subtract 31, or 79 subtract 30. Okay? So worth just very carefully doing these things, otherwise you're going to make a mistake. And 79 subtract 30 is much easier than 81 subtract 32, and it gives us an answer of 40. So we're going to have 9 plus or minus the square root of 49. 49. I am tired this morning. Okay. And that going to work out really nicely. So if we just continue this, let's put a little star, continue this here. So we've got 9 plus or minus the square root of 49. Well, that's going to be the square root of 49 is 7. So let's write 7. Okay. Over 4. And it's a good idea to now rewrite this instead of trying to work out this plus or minus. So let's make this a little bit neater. So I'm going to write it out more fully. X equals 9 plus 7 over 4, or x equals 9 minus 7 over 4. Therefore, x equals 16 over 4 equals 4, or x equals 2 over 4 equals a half. Now, going back to our graph, does that make sense? Well, yes, it does, because we did say that our intersection was going to give us a fraction. A half sounds about right, and 4 is our intersection there. So our answer then is x equals 4, or, and, doesn't matter which one you use, depends on context, and 1/2. Okay, so there's our answer. Now, we could, for the sake of argument, think about how else we would solve this. We could have factorized this. If we factorized it, we would then get 2 binomial expressions, and we use then the zero product principle to find those 2 values of x. We could also have used completing the square, and I'm tempted to do that because it's a lot of fun. But I think what we'll do is leave it for now. There's the worked solution. There's the idea of using the quadratic equation to solve things, but also what this question shows you is that a graph is another way, added to the list of many ways that there are of solving a quadratic equation. So the intersection of these two lines also gives us our x values, giving us the answer x equals 4 and a half.